stream. Sorry, I'm a couple minutes late. I made the horrible mistake of trying to get all the recycling out before the stream started. And I just didn't even get close, and I think I just made it worse. But on the bright side, we might have some interesting shots of Tuco playing in the pile of boxes. Let's see if I have my remote. Because, you know, cats and boxes. Oops. Autofocus. Huh. I wonder if it's something about the kitchen light that makes the autofocus not work. Yeah, maybe there's some modulation in the lights there that makes the autofocus totally wig out. Anyway, I guess we'll find out. So anyway, the streaming setup, besides there still being kind of a box mess, I did have a chance to get some more kind of camera stuff set up for the machining closet. So the plan for today, or for tonight, is actually to make another variant of the Facedancer that's actually intended to be a little bit faster by running on a Raspberry Pi and kind of cutting out one of the intermediaries. So we'll give that a shot by milling a circuit board and then populating it using some spare parts that I have here. And then we should be able to run the, and I'm terrible at announcing on Twitter and trying to describe the stream at the same time. We should be able to actually get the kind of Facedancer based version of that debug dongle from last time, that TCP87. We should actually be able to get that running at potentially a reasonable speed. So I guess we'll find out. So live again, milling PCBs and stuff. Let's post that, and then we can get this going. I will give you a tour of this board that we're starting to make. Oh man, except maybe Tuco wants to play first. All right, Tuco. Hey, kitty. All right, you want a little bit of Bolt before we even get started? Well, Tuco's going to have an especially fun game of Bolt, given that I have this terrible pile of boxes from my partially complete effort to take out the recycling. But my embarrassment is Tuco's playground. This will give me an opportunity to open up the chat. Hey, Tukester. All right, how are we doing on the stream quality? It looks like OBS is up to 30 frames a second. There's so many separate bottlenecks here. I was trying to optimize it for this new screen that has a view of the computer attached to the Othermill, as well as the Othermill itself, as well as a Chromecast that I can point a handheld like Android phone at. So I got it working smoothly, but it required kind of tweaking the resolutions to be within this computer's CPU and GPU capabilities. And I think some of it might be related to the encoder still, because decreasing the encoder bitrate helped quite a bit. Good job, Tuco. So I have this cat that's addicted to catching bolts. Pretty weird. Oh, there's a question in chat from Kenneth about what I'm running the OBS on, and yeah, it's still running on a Mac Mini, which is not the greatest. I chose it at the time because I already had a couple of these HDMI grabbers that only worked with Thunderbolt. But I think, with hindsight, I thought that machine would be fast enough, and it totally feels way underpowered for this job. So I'm going to try to find eventually some kind of, I think the next upgrade step, when I feel like putting some more money into that project is getting a faster Windows machine with a good GPU just for that. And you know, like it might be able to share my other Windows machine, but I also want to be able to stream from that machine. So like I think I just need a dedicated machine to run OBS like while I'm streaming when I have this many inputs and stuff going on. And I think for capture, I've started using a couple of these USB 3 capture dongles. They're actually pretty good, but I don't know if I got theoretically 2 more of those and I was doing 4 channels over HD or over USB 3, I don't know if that would work out. And for a little bit more than the cost of 2 more of those cheaper knockoff Madewell HDMI capture dongles, I could get like you know, a Blackmagic board with 4 inputs. With, you know, it would cost more to get all the SDI to HDMI adapters and stuff. But I think that's the next upgrade path to get higher quality streaming out of this. Such a cat. Okay, we're still getting reports of some bad quality, so I'm just going to try restarting OBS because maybe we just got a bad something or other. I'm getting good frame rate on the monitor here, but yeah, this is weird. So I'll be right back. Hopefully. Wow. Hey Tuco, you really want to play, don't you? Where's the bolt? All right, we should be back. Hopefully that didn't drop out too badly. And I did restart OBS right before this stream, so I don't know if this does fix it. I don't know why it would fix it, but it seemed worth a try. All right, Tuco, you want that bolt? Okay, initial reports are that this is looking better, so maybe I'll throw the bolt for Tuco a couple times while I open up the project we'll be working with on the computer here. Oh, actually, maybe I should, while we're in the playing fetch with Tuco stage, I have a new camera option here that we should check out. So this is just an Android phone, but it's doing screen mirroring to a Chromecast, which is then plugged into my capture setup here. So this is what I was going to try to get some video that's both streamable and locally recordable and wireless for the milling that we do tonight. Hey Tuco. This looks pretty high definition on the actual screen. And I think the camera in this phone is pretty decent. Anyway, this is much more convenient when things are more stationary though. Hey Tuco, where'd the bolt go? I don't know where this particular bolt went, but I see a bolt over here. So if you saw the previous streams on the Facedancer, you might have heard about its architecture, how it has this USB controller attached over SPI. And then there's a small microcontroller, an MSP430, which takes commands over a serial port, which is attached over an FTDI serial converter. So it's kind of a long chain of things, and for a lot of reasons, it's slow. And so there's a variant of it which is largely software compatible with the Facedancer, but it runs on a Raspberry Pi and uses its SPI port. And it was actually created by Philip. I'm not quite sure how to pronounce his name, I'm sorry. But he's actually another POC or GTFO contributor, and he created this Raspi Dancer, I think it's called. That's this kind of variant of the Facedancer that uses the Raspberry Pi's SPI port. And I think it can run that SPI port at up to 35 megahertz, so it should be a decent speed boost. And so as far as construction, it should be very similar, in fact, actually much simpler than the Facedancer, because I think it just has that one chip and some passives, like a crystal and some capacitors on it, and a jack. So it should be a really easy build. I think it's just a PC board that is basically just that part of the Facedancer, but with the right GPIO headers so that you can just plug it directly into a Raspberry Pi and then run this modified Python module with it. Oh, I'm still getting reports of bad streaming, and I'm just realizing that I forgot to turn off my backups, which are probably using up all my upstream right now. So, sorry about that. Okay, sorry about that. I just recently started trying to do cloud backups for all my video material, and I usually have it sucking up all my upstream, and I remembered to stop it for the last stream, but I forgot. Well, I had it like throttled way down. But yeah, that should help. Let me know if that's an improvement. In fact, I should be able to ask YouTube if this is an improvement, right? YouTube is saying my video output is low. Hey, Tuco. Tuco, where's the bolt? No, I'm so bad at multitasking. Okay. Video output low. Oh, jeez. Well, let me make sure the backups are actually filled. Sorry about the technical difficulties. Backups are definitely paused. And let's just restart OBS. Be right back. Wow. Alright, Tuco, where's the bolt? Are we back? Are we back? I think we're back. I think we are back because of actually pausing the backups and restarting OBS. I think those were both necessary steps. Alright, YouTube still says my stream is good. Tuco's still playing in my pile of trash. Tuco found it. So I should have those backups paused at least for a couple hours and then throttled back to like 500 kilobits, which shouldn't affect us. Yeah, rookie mistake, sorry about that. I was spending so much time testing my OBS setup that I forgot to make sure that I had enough bandwidth. Hey Tuco, you got that one? Good job, boy. He does really like going down that hallway that leads toward the machine closet. All right. Thanks for bearing with me, and thanks for the reporting back on the stream quality. I think we're good now. I think that was mostly a bandwidth issue. Cool. Well, I'll throw a couple more bolts for Tuco while I load up the files we're going to need on the computer here. I think we're mostly just dealing with the GoodFET repository, which I already have handy. Hey, buddy. Did you drop it all the way over there? Whoa. It landed on something soft and confused him until it rolled off of the beanbag chair there, and then he heard it. I'm glad that he's not interested in my half-eaten sandwich. That's one of the perks of being a vegetarian. Cat is so disinterested in almost everything I eat. He is interested in the boxes, though. He's getting distracted even just as he brings the bolt back. Yeah, I was going through the boxes to, to break them down, or at least to start to, before I realized I didn't have nearly enough time. And yeah, I can see the strata of different kind of tools and bits of hardware and beer and everything else that I've ordered in the lab. I think well, and then of course, there's this delightful moment when I find, oh, there's the biggest box. This one will hold all the others when I take them all out to the dumpster, which is depressingly far away here. It's like half a block away, which is part of why the trash builds up. But I ordered this cheap rack mount server to run fuzzers on a little while ago, and I've still got the box that came in, and it was a huge box. A very heavy machine. This looks like a hard one. I don't think you can see Tuco at all. Oh, maybe I can use the wireless camera here and we can give that a quick test. Is this working? I know, Tuco, you're working on it. You're so persistent. You getting it? Is it too hard? I think it'd be really easy if I move this back for him, but I think he can get this. You want help, Tuco? Let me move this stuff. Got it? Oh, I think it's under this bag now. Is that too easy now, Tuco? Actually, I'm wondering if maybe it's not that obvious bolt, and maybe he's looking for it in some less obvious place. Because he's just ignoring this bolt right here. Alright, maybe he just wants another throw. Did I throw that the wrong direction, Tuco? It's okay. I should get back to work here. We should throw from this direction. That's what you wanted anyway, isn't it? Alright. Oh, there's a comment about some other apps that make your phone into a wireless camera, and I've tried a handful of different things, but the screen mirroring that's built into either iOS or Android, they actually both work pretty well, is way better than any streaming app that I've seen. With maybe the exception of, the name escapes me right now, but there's like a commercial app that's basically a competitor to OBS that's like $500 or something, and I think that includes an app that will stream like actual H.264 video over the network. But most of these IP cam apps are actually just like streaming motion JPEG and not even at a good bitrate or resolution. I've had some luck with those like on an Android phone just for keeping track of 3D printers. But in fact, like the camera that I have in the machine closet, we don't need shaky cam anymore. The camera that we have over in the machine closet is actually just like a little embedded Linux thing running MJPEG streamer with a webcam plugged into it. Tuco, do you still want to play? I'm pretty sure Tuco still wants to play, but let's let's move this forward while helping the cat get some action. Oh, that's right. I had these things on my desk still. I'm still not quite sure what these are going to be for, but I was experimenting with this. I don't know what I was trying to do here, but these are basically 3D printed molds that I press colored putty into, and then you bake the putty and it hardens. And it also kind of warps the plastic a little bit as you bake it, but not too much. And there are probably some ways to mitigate that. But it's not even an unpleasing sort of warp for this. So the plastic is PLA, and the putty that I used is it's this polymer clay. So it's not really clay. It's like basically plastic plus a binder that evaporates when you bake it. So it actually kind of bonds together into something really hard. I've like actually tried to break one of these just by like throwing it really hard at stuff, and they hold together. It sands really nicely, so these are sanded to finish. So yeah, not quite sure what this sort of thing is for, but I used it for a video for the stream, or a photo for the stream, and they might have some other uses in the future. Might try using this to finish other kinds of 3D printed objects, possibly with like lights embedded into them, that kind of thing. Tuco, you still want to play, right? That's what this is about. Where's your bolt? Really speedy little cat. Okay, so let's just grab the GoodFET repo. I think I actually already just have a checkout here that we could use. Yeah. And the stuff we want is in contrib and contrib and then Facedancer. Ah yes, Rasp Dancer. Great. So I'd heard about this project, but I didn't realize the source was actually just in the GoodFET repo. Let's see if it actually has a web page too, so we can get that on. Oh, I was going to say get this on the recording, but I haven't actually started the recording yet, so I should do that too. Oh, he's talking about it on Twitter. It's a pretty sparse web page. Well, it does have the schematics handy, which is nice. Let's get the screen recorders and the audio and all that going. Oh yeah, there's a note in the chat that there's some video glitching, and I'm seeing that too. I think that's still something up with the... I don't know, I've been trying to track it down. Like there's something in this chain of HDMI devices. The video recorder is going to reinitialize some of this, so that might change the situation. I'm not seeing any glitching on the recorder, so oh, you know, I wonder if when the recorder goes into sleep mode or something, if it switches out the because I think the streaming HDMI grabber was connected to like the through output of the other Elgato HDMI grabber. So maybe when it's in sleep mode, it just connects something that's electrically less sort of amplification-y. You know, maybe it just like connects it straight through instead of actually connecting it to the output of its FPGA or whatever. Because yeah, the other recorder is not glitching, and I don't see any glitching on this stream output anymore. Tuco, you still want to play, right? Oh, here's a bolt. Yeah. All right. So this does look pretty basic. We've just got a header, a couple of passives, connector, and this should just be a subset of the components from the Facedancer. There's a prototype. And so this is another kind of contributed schematic and board for Raspdancer. So this is what I want to try to make. This Raspdancer 21. Razdancer. Face Razzer. Hey, Tuco. So it is a two-sided board. It does have a bunch of vias under the chip here, and it doesn't look like we could easily move them without redesigning the board, so I think we'll just have to deal with that, which is fine. We had the same issue on the actual Facedancer. But yeah, this will be a quick little fab, and then we can use this to see if that speeds up our other experiment using the Facedancer to emulate that debug dongle. And just to have the best Python performance, I can stick this on a Raspberry Pi 3. So there's also a Beagle Dancer, which is another option. I don't think I have a spare Beagle bone. Oh, actually, I might, because I recently got one of the Bela kits from their Kickstarter, and it includes a Beagle bone. But other than that, my only Beagle bone is the one driving my 3D printer, which I don't want to take out for experiments. So actually, this is interesting. This might not even require any hardware. Well, except there is a hardware directory. I guess this does use probably the same chip. I wasn't sure whether this would use the built-in USB support on the BeagleBone, or whether it would use the same Maxim chip. But yeah, it looks like they're just using the same Maxim chip. So since I already have more Raspberry Pi stuff around here than BeagleBone stuff, the Raspdancer does seem to be the right option here. So I think this is an EagleCAD file, so we can pull it up in Eagle just to look at it here, but then I think we can just open it directly in the Othermill software and make one of these boards. This chip is pretty thin pitch, so I think we'll need to use the angled engraving tool again instead of the flat end mill. Oh, okay, I got a hint in chat that Dominic was working on that other thing that I thought existed, the USB Gadget FS support, that was in a separate repo called USB Proxy. But yeah, I'm not sure if he ever finished that. Okay. Well, I think this Raspdancer seems like it's worth a try. Like it seems likely to work well enough, and it seems like it's somewhat well supported and is a thing that, you know, will both make a good kind of assembly demo and a good USB hacking demo, because I plan to try to get multiple plan to try to get as much mileage out of this footage as I can. Hey Tuco, you really want to play, don't you? Where's your bolt? Where's your bolt, little guy? Oh, this cat. Yeah. I just noticed a comment from the chat that I need a robotic bolt thrower for Tuco, and I have one that's a work in progress, actually. I should get it out and show you how badly it works. Let's go to the big Tuco cam here. So I have this box auto bolt What do we have here? Oh yeah, this one's the most recent design, but it's a little bit glitchy. Yeah, Tuco. And again, this is always the dilemma I have, is I'm always choosing between actually playing with Tuco and working on a machine that plays with Tuco. And there's only so much energy I can put into the machine without just playing with him. Hey Tuco, where's the bolt? Where'd he go, little guy? Oh, Tuco, it's easier to throw the bolt if you bring it where I can see it. All right. There are probably better designs for this. This version of it was sort of a like a wheel that you would put over a like a brushless DC motor, and so it would spin really fast. So it would spin kind of in this direction, and then it would have a hopper above it. And so the idea would be that Tuco steps on a lever that causes a mechanism to move where the hopper dispenses a bolt that falls onto this thing that's already spun up, and then the bolt flings out, and then he chases it. So this is a later version that I made for a brushless motor. It's all right, actually. I tried it. It's fine. But it's just this particular way of throwing the bolts doesn't really impart that much energy to the bolt. It just kind of like pings once without really like following through. So something with 2 pinch rollers that both contact the bolt and kind of push it along would probably work better. This first prototype this was also flexible. Has a little like CD-ROM motor and a bearing on the other side. Yeah, Tuco knows what these are for. Maybe he can just hang out with my prototypes while we're working on something different. All right. So let's get these designs out. I think we just want to open up an eagle. I never can actually trust double-clicking on any kind of EDA file because too many of the file extensions are ambiguous. Let's start with the schematic. That's not the zoom I'm looking for. All right, that's pretty simple, and it matches what we just saw on the website. This might make a slightly cleaner recording than the website, but yeah, Max 3421E, Raspberry Pi header, the small version, and a couple of USB ports. Let's take a look at the circuit board. It's so cute. Great. And just to make sure that this loads in the software, I'm just going to first open this up in Othermill just to look at it there. But then we'll go into the closet and have this very sophisticated setup that's mostly just VNC, where we can watch that computer while I'm in there. All right, done with Eagle. Other plan. Yeah, it knows the machine is disconnected. Face dancer. Great. So you should be able to get an idea what this looks like. And I think we'll need to use a pretty shallow depth. Like last time we were using 0.15, but yeah, I think we need something even less. And we can tune this once we're in the machine closet. But it'll look something like that. And then 1/64th for the holes. Yeah. So we'll have to tweak the engraving part for the actual Z height of our material, because that's quite sensitive. So I'm going to try to take kind of what should be an air pass, or at least like a very light pass that doesn't cut all the way through, and then narrow it down until we've just cleared all the traces we care about. Because that's the most reliable way I've seen of calibrating this, to first go through and set the trace depth. You want this to be as high as it'll go without having areas that you can't machine. So what is that? I think that cut through, but I think at 16, for example, it can't get all the way through here because it's not. It tries to go all the way down so that the point of the tool is at 0.16 millimeters below the surface, and at that depth, the tool is too wide. So I could use a narrower tool. I think I might have a 30 degree. I've been using 80 degree because I've got a couple of those handy. But the other way to solve this is just to cut shallower traces. So I think if we go down to just like 0.14, now the simulation shows it clearing. And so this means that it's going to give me a tool path which at least cuts through all of these areas instead of just failing to even give me a tool path. And then I find it useful to then adjust the Z height so that I'm just barely getting the kind of clearance I want here. Because if I cut too deep, then all the gaps between traces, those will end up being too wide, and stuff like these thin traces will end up just disappearing, and I'll end up losing that net. I have to run a flywire. So I think that's good. I think I can go wireless and we can go to the machine closet. But yeah, the software is pretty nice. It won't look quite as nice on the slow Windows machine I have attached to the mill. Speaking of, that is a VNC client attached to the mill, and all right. Hey, Tuco. Tuco really wants to. I don't know what Tuco wants to do. I think it involves bolts, but there we go. That's what I wanted. So I just need to put on this wireless headset, and then we can go to the closet. Oh, Tuco knows what this headset is. Hey, Tuco. He often likes to hang out in there with me. It's a little bit annoying because he'll often get into stuff, but it's, I like having him around. All right, I think we are good with the wireless. Let me quickly check in the headphones. How does that sound? Check. Yeah, all right. Wireless audio, wireless video. Hey, Tuco. Let's go do some wireless milling. Let's also make sure we have the recorder on, because I want to record. Well, I'll record from this phone. I've also got this recording from the machine with the VNC client. I've got the audio recordings. And I hate that. I was going to use OBS to record another stream directly from the mill. Okay. Just got that recording. So much technology happening. Hey Tuco, what do you think, technology or boxes? So, bot closet. This is here, let me do a quick bot closet selfie. How do I do that on an Android? Yeah, alright, so what do we got? The all-important hearing protection and fire protection and height adjustment. Some cameras and humidity dongles. Networky doodads and beehive. That's not an actual beehive, it's just the rack mount machine. It's not on right now, you would be hearing it if it was on. So then over here, there's a shelf with the actual mill. It's very little, but it's good at circuit boards. And the really, really minimal Windows machine that's running it. This is my main 3D printer over here. It's the Type A. It's pretty awesome. I'm using a rubber heat mat to heat my bed a little bit. The secondary 3D printer down there, a little Delta machine. So, this first step is just to download that PCB on this machine. Let me switch this back to non-selfie mode. Clearly I'm not very good at using Androids, or at least this particular phone app that comes with this particular Android. Alright, normally I would have stuff like this like on my network drive, but I am just going to download this directly from the Git repo, I think. Oh, you know what? I should have like a little phone stand in here. Yeah, let me find a way to put this down when I'm not like inspecting something. You could see my eyebrows while I work when I put that on the shelf. Files. That's what I want. Okay, I've already got this on the machine from before in my... I don't think I downloaded the repo that time either. I think I just grabbed the file directly from GitHub, which is convenient. So contrib, face dancer, rasp dancer, and I think I just need that PCB file, that .board. Yeah, let's save it there. All right. I want to open that fresh because I had some other stuff loaded in there for testing. I'm going to grab a phone stand and the laptop screen, because if this is broken and people are trying to tell me, I'd like to know about it. Phone stand and lappy. Oh. Did that lappy just reboot right as I grabbed it? That's not a good sign. Maybe it's low on battery. Maybe I will put this on to charge instead of taking it into the closet. I think I might have forgotten to plug it in. Sorry if the stream is broken and you're trying to tell me on chat and I can't see it. Oh yeah, apparently it's getting Windows ready. So maybe there was some power/update event that I was not aware of. I'll let that do its thing and go back to the closet, sorry. At least I've got a phone stand. A cute little 3D printed thingy made out of Ninja Flex. Well, semi-flex. I think this might help. Kind of. I'm just going to balance this on top of some Kapton tape or something. Alright. Okay, I think that's better. I hope the stream is still healthy. So, there are a handful of options here, but we should be able to... did that not actually save? I actually wanted that thing I just closed. I'd really like to just save this without any modifications. Yeah, I think it just gave it a .text extension. Board file. Whoops, not that. No, that's so meta. I'm trying to open the 3D printer in the mill. Hey, Tuco, you want in? You want in, little guy? It's so weird in here, isn't it? Hey, little guy. Yeah, Tuco likes exploring. Alright, let's try that for the moment. Okay, let's do this properly without failing at basic computering. Yay, we has board. So I had this set to bottom before, I guess. Doesn't matter which one we mill first. Hey, Tuco. Guess we might as well mill the bottom first so we don't have to worry about putting those delicate traces down on tape. Oh, except our... Yeah, that's the bottom, which is less delicate than the top on this board. Hey, Tuco. You want to explore stuff? So, anyway. Let's see. Let's get some stock. Let's see what we have available. I think we could just stick this on some of the leftover stock from that previous job we did. Tempted to trim this slightly, but I don't think that's even necessary. So, let's go back to actual camera mode and not self thing. And let's go ahead and just start recording this. So that's the stock we're starting with, nice and, yeah, relatively consistent. And I think I'm going to use, so we're starting out with milling the back and lining it up to the bottom right corner. We could change that, but it's easy enough just to pick that location on the stock. So I'm just going to use this corner. And it's a little long for the mill bed, so I'll either have to trim it or just be really careful not to home the machine while it's in this steep. So yeah, maybe I'll just do it this way. It's a little more surefire than having the piece rotated, since these are pretty much cut to the size of the bed. So, alright. Let's just do it that way. Make sure that we have this measured. I like to measure it at a couple of different points just to make sure I'm getting kind of a consistent measurement. So, actually the easiest way to cut the traces pretty incrementally, well, we have two choices really. We could change the thickness or change the Z height. So that 1.62 that we just measured is already in there from the previous job. So let's just use that as the thickness, since that seems like a pretty good estimate of what we're actually dealing with. But that doesn't account for the size of the tape, and it also doesn't really give us any margin for error. We'd much rather be too high on the first run than too low, so we'd rather hover a little bit above it. So last time I used 0.25 to account for both the tape and that margin for error, and it actually turned out to be just right, which I don't want. I want it to still be a little bit too high so that we can tune it. So let's start with like 0.35, which should be like, shouldn't even touch the copper, but we can tune it from there. And I'm going to start out not even worrying about the holes or the outline. I just want to get the traces dialed in, because that's where there are a lot of mistakes to be made. So if I have to start over, I don't want to have other work that I have to discard if I can avoid it. So I think that's everything for the config. Tools, of course. So traces only, and we don't need any end mills for this, but just the 80 degree tool, and we'll use that cutting depth that we saw from before that worked fine for the other side, and then just verify it here, because I want to make sure that we use the same parameters on each side. But I don't know why I'm bothering to hold the camera in front of the computer screen, because that's got a higher quality recorder anyway. Oh, it looks like actually 0.14 isn't quite small enough for this side. So let's go a little shallower. Does 0.12 work? Huh, no. Well, 0.10 works. Yeah, I guess we have to go all the way as shallow as 1 millimeters to cut that one little gap in the I don't know if you saw where that marking was, but it was right between this via and this trace. So if we were designing this board or modifying the design for milling, then we definitely want to open that up a little bit. And if we had trouble with these settings for the rest of the board and just needed that close tolerance for right there, then we might just do that manually afterwards. But I'm going to see if I can find settings that work for both sides. So that's 0.1, works on the bottom. And it should work on the top, since I think we already tried 0.14 successfully on the top. Why am I not seeing any traces now? That's weird. You know, I think this might be like an Eagle import issue. Huh. Well, maybe we'll need to go with the Gerbers, because I think it's got like some kind of coordinate system misunderstanding going on here. So, alright, in that case, the stop recording with that right now. Alright. Just download the zip here. I don't know if I have Git on this machine. This is like the slowest possible Windows machine that'll run the Othermill software. So I'm just going to copy this directory out of the compressed folder. I think there are already Gerber files in here from EagleCAD. Yeah. So the Othermill software also knows how to open those, which those are just the standard interchange. Well, there are a bunch of kind of loose standards, but it's the collection of de facto standards that everyone has to deal with when they submit boards for manufacture these days. And all these files starting with G are individual layers of copper or silkscreen or mask. And then the dot, I think the .txt here is these are drill coordinates. And the Othermill software should be able to load all of this on its own. Alright, open files. Heard Tuco just get into... Oh. Yeah, Tuco is exploring the current state of the recycling pile outside the closet door. Okay, so I think the way we can start this off is if we open the GTL file, that's the top copper layer, and then we should get another dialog with all the other layers that it needs. And it's getting these kind of default extensions, which should be fine. I don't think we have a separate outline layer here. And it crashed. Sorry. Let's try that again, just in case it was a transient problem, but then maybe we have to re-export these. I think I already double-clicked it. Maybe I didn't. Sometimes I end up with 2 instances of it open, which is not fun. Let's try that again. GTL file. Nope, same thing. Seems like a problem in their parser that I'm triggering. Well, maybe let's go back to the other computer and try doing a fresh export, just in case something is weird about these files. Be nice if we had more data about that, like where the error was. Alright, going back to the desk. Camera. Can we house camera? Hey, Tuco. All right. Oh no. Well, I guess this failed to mirror somewhere along the way. Sorry about that. Let me turn that back on. Hey, Tuco. I hear you, little cat. Man, the connection between the screencasting here was like it didn't seem to disconnect for pretty much any reason. Like the phone, I put it to sleep, would switch applications, wake up. It seemed fine, but something that happened there caused it to disconnect. Sorry about that. And Tuco really wants something. Alright, let me open up chat and get EagleCAD back open. And let's try to get some files that... You know, it's weird, though, that we didn't have that crash on this machine. Let's see if they're running different versions. I mean, obviously they're running, like, one's Mac and one's Windows. I think they're both running 1.0. You know, I wonder if it's just a bad copy of the file somehow. Like maybe the Windows unzip did something horrible to it. Hey, Tuco. Let me just try throwing these files on a USB stick just to have something reliable there. Hey, Tuco. And let me get the chat actually open so I can see if you're all telling me that this is completely broken and that you've all left. Tuco, what do you want? Is it time to play fetch with the cat who's extremely needy right now? Meow. Maybe he wants something that's like a normal cat thing, like dinner. Do you want dinner or do you want a bolt? It seems like the stream is still alive. So, okay. This is weird that, like, this seems like the same version of Otherplan, and this is like their cross-platform version of it. So on this machine where I was successfully reading them, I've got Otherplan 1.0.0, which we can check on the other machine, but I think it was the same one. So I'm just going to put these files on a USB stick, just so that we're sure that it's the same stuff. We also might try going back to the EagleCAD file because, like, that was loading. We were just having, like, maybe a coordinate system problem, and maybe that's something that's fixable. Like, that might have been a bug related to placing it while it was on the bottom or something like that. Because I think I've seen it do that before, but I don't know if I came up with, like, what the actual scenario was that caused it. Alright, copy of the GoodFET repo. Tuco, you're so patient. Where'd it go, little guy? Tuco, you must know exactly where it is, and then you drop it, and the dumb human just can't find it, and you're like, but the bolt. Wow, it's gonna take like a minute to copy 85 megabytes. Hey, Tuco. This makes me wonder if, like, there's something seriously wrong with the USB hub I plugged that stick into. Good job, Tuco. Meow. This is the slowest file copy. Why? I wonder if it's something about the way that USB stick is formatted. I think it might be like old school FAT instead of FAT32. Well, I'm kind of glad I didn't finish cleaning up the cardboard before this stream, because Tuco's really enjoying this. Okay, I've got these files copied. Let's see if this works any better, and if not, we'll try to diagnose it on that computer. Try to slowly eject this USB drive. And is this computer going to be charged up enough that I can carry it with me? I think so. I don't know what I did to cause it to shut down before. Is that still having trouble ejecting? The USB gremlins are infecting my system. There it goes. Alright. What channel do we want? We want mobile thing. Yeah. Great. This whole complicated thing. Alright, let's go to the closet, Tuco. I mean, I'm gonna go to the closet. You can come with me if you want. There are so many things you can blame USB gremlins on. Like, yeah, you work on USB for any length of time, and I think it just feels like they could be responsible for absolutely any problem you can imagine. All right. I'm sure Tuco can get in if he wants to. Okay. Delete that. So I don't know why the camera app does that thing where like it times out and you have to touch it every so often. I assume there's some other Android camera app that I could install that would be slightly better for this purpose. Because I mean, now that I can use the kind of stream or the screen sharing to do the hard part, just need something to put the camera on the screen. Things. Great. Just giving the stream a check on the tablet here. Oh, wake up. Okay. All right. I think we're good. Face dancer, rasp dancer. Let's try just opening the Eagle again to see if that does any good, and also we'll make sure that this other plan is actually version 1. I just have to remember it takes a long time to load on this machine. Okay. So maybe this was not an irreparable problem with the Eagle parser. Maybe this was just something where I had to try again without some kind of configuration weirdness that was going on before. So, tap the phone again. Let's get back to the settings we care about. So first thing, just the traces. We've already got the dimensions here. So the X and Y, they look right. They're also not super critical. The Z, we definitely need to be correct, but I remember that 1.62 already matches what we measured just now. So tools, on an 80-degree engraving tool, going 0.1 millimeters deep. All right, 0.1. Okay. So that should be what we're looking for. Cuts out all of our traces, 80-degree tool, and this Z set to 0.35 should make it pass very lightly, if at all, over the copper. So first thing, we're just going to try that and then adjust the Z height as necessary. Alright, so this is all fine. I'm going to click start, and then it'll ask me to change the tool. I see that video output low message. This is definitely the most CPU intense layout that I'm using right now. I don't know what the best camera angle is for any of this tool changey kind of stuff. I don't know. Anyway, need to put the, oops, sorry. Need to load the circuit board and the tool here. That doesn't really do what I want it to do. Crotch cam. Alright, I'm not going to worry about this too much until the mill is actually doing something interesting. Yeah. I'm going to be mostly putting the tape under where it's milling. Okay. So I've got this tape on the back of the board. And you'll get to watch me try not to cut myself while holding the camera and trying to do this. Oh man, yeah, this is some of the worst camera work on my channel. This is not going to end up anywhere. Sorry. It currently don't have any kind of little like phone tripod thing, but I think that's what I need for this, and I got one on the way because they're not expensive. It's just not something I've needed so far. So let's do loading first. This little, it's like this phone is kind of a nice camera in so many ways, except it doesn't have a tripod mount. So I'm going to solve that with the addition of an adapter of some kind, but it is an oversight in the design of the phone. This was one that I picked up for like Android baseband related stuff, and then mostly have used for photos and videos since. Okay. Yeah, I don't know if any of this handheld stuff is actually going to be useful without the tripod. I think mostly it's going to be nice to get a closer in inspection of the results between passes, but well, that's what I got right now. So, loading done. Let's get the tool change started. Oh yeah, I thought about doing a head-mounted camera. Yeah, I don't know if I have a good thing for that besides just like taping the camera to my face right now. Which actually the main problem I can think of with that is that I would inadvertently end up pressing buttons and stuff, and especially if this thing wants to go to sleep every, who knows how many minutes, unless I prod at it, then I need the screen to be accessible. So, and then, yeah, Google Glass maybe. I don't know. I don't know if the camera in those was even any good. It's my tool storage solution here. I've got kind of my most frequently used tools over here with the bit fan still mounted on them, and then some of the other more common ones, and then some of the less common ones down here under where the tablet is right now. Okay. So this is actually the scary part where it does the tool height check, and it doesn't need the window to be in for this, so I can get a close-up recording of this. Well, as close as my focus will allow in here. Moving slowly down until it uses the electrical conduction as the tip just barely touches. It might even actually be capacitive, so it doesn't quite have the touch, but it gets a pretty consistent Z reference that way. And it's not going to go any further until I put the door back on this thing. It's waiting for the reboot since I put the door on. Did I confuse it by putting the door back on at just the wrong point in time? I might have to pause it and resume it. There we go. It looks like an air pass, which is what we wanted. So that's still pretty far up. I think I'm going to go down to 0.3. So same everything else. I'm just going to go down by 0.05 millimeters, which if we were working with Pyrolux would be enormous, but I think here the value we're looking for is probably a little over 0.25, possibly exactly 0.25, since that's what we used last time. So 0.3 is going to be closer. So same settings, just that. Oops. Anyway, yeah, this is still an air pass. I'm really failing to hold this phone without inadvertently focusing it on the wrong things. Okay, so that was 0.3, still an air pass, although, yeah, it looked really close. Let's try going down by maybe about half again and do maybe 0.27 millimeters. We might have gotten really lucky with 0.25 last time, if that still turns out to be about right. I don't think it's cutting at all, but we can take a closer look and see if it's even making an impression. Let's take a look and see if that was even touching. Nope. Still totally untouched. So that was 0.27. So, you know, I wonder if maybe this is going to end up being a different number than last time. Maybe this particular side of the board is thinner. But let's go down to 0.26. I'm nervous about 0.25, but you know, let's try going slowly. And so this kind of precision is only really necessary when you have such fine pitch parts. No. Yeah, maybe the tape is thinner on this board than the previous one, because I mean, given how 0.25 was like just the right depth before, I mean, there is going to be a point where it'll cut some but won't break through, and that's going to be wider than like 0.1. So let's go all the way down to 0.24 millimeters. All right, 0.24. Yeah, a little deeper still. I don't think it's even touching yet. It's always concerning when the number is like much different than it was last time. It's like, what am I doing wrong? But it's like definitely taped down. I didn't forget to tape it or something. But yeah, let's go all the way down to 0.2, because I don't think it's touching at all. And I don't think that's going to be too much. Let's try it. seems suspicious here. I mean, I still haven't touched it. Just to rule out one potential thing that might ruin my day, I'm going to try... It got a good... in the way or something. So, I'm going to just do that really quick. So, I don't think there's any gunk on there. I might just be paranoid right now, like maybe this is just a thinner side of the PC board. I just felt it worth taking this precaution. Okay, and this is probably just going to be another air pass, but I'm going to set this to 0.25, which is what I cut my last successful board at, just to make sure that that rehoming didn't make a significant difference. Because I wouldn't expect it to, but this is just a test for that. So back at Z at 0.25. Okay, same result. So I think either I'm going to chalk this up to board variation, or it possibly might just be down to how my... I don't think I've cut with this particular trace depth on FR1 before, so maybe it's something to do with that. But probably most likely to be board variation. So I'm going to go... Let's see, we were at 0.2 before. Let's go all the way down to 0.15. I'm just getting closer to what I was measuring the tape at with the calipers. Oh, now it's cutting. Well, we're pretty much committed to go at least this deep now. So I guess we'll see whether this is too much. going to take a look at the streaming machine to see if there's anything I can improve, because it looks like we might have a slight bandwidth problem. Well, OBS is at 30 frames. YouTube is complaining about the amount of stream it's getting. Oh yeah, there's a comment in the chat about maybe there being an air bubble in the tape last time. That's totally possible. It could have also been, I don't know if I was careful to use that method with the knife to put the tape on last time, so I might have like scrunched up the edge of one of the pieces of tape to make it thicker. Tuco stole my chair out here on the desk. Oh, so Milo in chat asks the offset difference. About 0.1 millimeters. Right now my Z height is 0.15, and my last board that I did with these materials was 0.25, I think. Oh, and there's also in a chat about the copper and the tools. Let me go through the rundown. I think these are 1 ounce copper boards. They're the ones that the Othermill shop has, so they're double-sided, and I think they're 1 ounce. This looks good. Let's take a look at it on the little camera phone thing. I need to make sure that this is still streaming. Yeah, okay. I think we've still got the camera. Alright. Let's get video. So that is our freshly milled circuit. And I think it looks fine. That that IC footprint for the Max 3421 is really the most critical part here, and that looks like it came out just fine. So I don't think we overshot. I think just kind of inching. I mean, I think that last jump down by like 0.05 was a little bit reckless, but it turned out fine. If this was a larger board, I probably would have milled a smaller area to test first. But yeah, that seems fine. So while we have it mounted on this side, I'll drill the vias and then flip it over, then drill the vias again from that side, which isn't necessary. I just like drilling them from both sides because then I get cleaner holes. And then mill the outlines. So on the software side, I just need to tell it... Let's put this back in the stand. Alright, so not milling traces this time, just holes with one. Let me write down this Z height. Oh, you know, there must have been something weird about the last run, because the numbers I have written down actually for this material is a Z height of 0.15. So, yeah, there must have just been an anomaly last time. And I don't think it depends on the... Well, that was with a trace depth of 0.01, so there is a bit of an interaction there, because I think what I was actually doing was cutting shallower, like telling the software I'm cutting shallower than I actually want to cut, and then having a slightly lower Z depth than I actually want. I guess what this is mostly telling me, though, is that there's still enough variation between pieces that it might be worth starting out, you know, a couple of hundredths of a millimeter higher than you actually want if it's a particularly dense design like this. Alright, so given that this varies so much, I'm not really going to bother writing down this data point. We've already got it in a stream anyway. So as far as Z height for the holes, I think last time I was using like 0.6. I'm going to use a little bit less because I think my holes weren't entirely cutting through in the middle. So, and really I just want to not break through, and I don't want to rub the shoulder of my milling tool, so I'm just going to go 0.45 for the holes. We'll see how that does. Tool change time. Tuco's having such a good nap out there by the heater without me. I guess if I had just an infinite number of presets in OBS, I'd probably have one that has Tuco cam turned on right now. I think that situation looks fine. Sounds like I might still be rubbing the tool a little bit, which isn't going to be a huge problem, especially not on those holes, but I want to avoid it. And it might lead to problems on the vias under the processor. So I'm going to back that up to a Z height of 0.55. So that'll be a little deeper than before, but like a full 1/10 of a millimeter higher than just what we were just doing. And let's try that again. All right, this one's going to take a few minutes, so maybe I can let the phone cool off and take a break to catch up on chat and pet Tuco. Yeah, Tuco took my chair over here. Hey, little cat. We can switch to the wired Tuco cam. YouTube is still saying I'm not putting out quite enough video for them. Do we still have sound? I still have the a VU meter on the OBS machine. Oh yeah, it looks like I was trying to answer questions, but the audio was skipping earlier, and yeah, so I think these are 1 ounce copper because that's the most common. I don't remember for sure, but these are the blanks that the Othermill shop stocks. I've got 1 pack of those. I'm keeping an eye on OBS and the stream. The bandwidth counter kind of bounces around a little bit. Yeah, maybe I do need to just upgrade this computer. I think the only thing I significantly changed since the last stream was to add the extra HDMI for the Android phone, but maybe I didn't successfully optimize the settings enough after that. Oh yeah, and if I didn't make it clear already, these boards are not fiberglass. These are FR1 type boards, so I think the inner material is like some kind of epoxy or phenolic or something like that, so like a plasticky, resiny kind of stuff. And then it just has copper clad on both sides. So it's much easier to cut and a lot less sturdy than a fiberglass board, so it's good for prototyping. And this part would definitely go faster if I was using like drills instead of end mills. That means that you pretty much have to have some waste material under instead of doing this method of drilling from both sides, which is fine. It's just another setup step. I like the end mills partly because have fewer tool changes. I can deal with a bunch of different hole sizes, and I just have to worry about a tool that fits in all of them. And for a lot of boards, you can get away with, instead of having this very finicky 80-degree tool. So I think if you use a 30-degree tool, it might be easier to tune. I haven't actually done much milling with a 30-degree tool. I have actually used smaller flat end mills to do a lot of boards. So like a lot of stuff with like a 64th inch end mill, and when I have to, going down to 1/100th inch. And those tools are annoying. They are really slow and they break a lot. But yeah, so it's actually a lot nicer to use the 80-degree tool than to use the 100th inch end mills, because it's just the tool lasts so much longer. But you do have to care a lot more about this height calibration. A lot of mills, you can configure that height calibration to 0 off of either the top of your material or the bottom. I think the Othermill only supports zeroing it off the bed. I mean, I think theoretically you could, like especially if you had copper clad and you connected, a good solid wire between both sides, and made sure to get that also connected to the build or to the spoil board maybe, but I have not tried that. I am not sure how easy it is to do with the software and hardware here. I mean, I can kind of understand why they want to mostly get the reference from the spoil board, because it's probably a lot harder to accidentally just plunge your tool right through the spoil board when the software knows where it is. Although, yeah, that automatic Z height setting with the electric probe is, like slowly lowering it until it completes a circuit. That I had that fail the very first time I used the mill. Like I think I was using it wrong, and I had the tool much lower than it thought it was, so it was still doing the phase where it goes down fast and doesn't check for a completed circuit. And while it was still in that phase and hadn't gotten to the part where it was checking for a circuit and going slowly, it just rammed the tool right into the aluminum plate there and broke it off. And that was like a really small tool. It was like a 1/64th, I think. That was a lesson. On these kinds of boards, the hole drilling is definitely the slowest part. I think the estimate was something like 13 minutes or 15 minutes or something. Maybe I should take another... Oh man, I'm hungry. I bought a sandwich before streaming, but I didn't have time to eat much of it. Just trying to catch up on chat a little bit. There's some more discussion on PCB materials. I think the stuff here, I did go looking for even cheaper PCB material because I had a project where I was trying to do like something kind of structural and kind of electrical out of PCB material. And so I wanted to get kind of a big quantity of stuff that didn't have to be especially high quality and didn't have to be two-sided even. So I just got this big box of single-sided FR1 from eBay. So I've got a bunch of that, and then I've also got some of this double-sided stuff from Othermill. All right, I'm going to turn off my headset momentarily so that you don't have to hear me take a bite of my sandwich. Hi, I thought I would do that before turning my mic back on. Hopefully it's actually on now. So that top side looks pretty rad. I think we're just gonna do pretty much all the same stuff on the other side. So starting with the tape. I'm mostly just covering the area we're working on, but enough that we can cut out the board without the rest of this going flying. Oh man, sandwiches are awesome. That was one of the nice parts of working at SFTO. We had a whole game about sandwiches. Which was like, didn't really mean we got to eat sandwiches any more often than, but you know, it was a nice theme, I guess. I was friends with the main programmer on that game, and it was one of those fun little social bright spots in something that was otherwise kind of a pit of workaholism for me, which can be good in its own way. I certainly like a good workahol overdose like anyone else. Alright, put the board back on the bottom right side of the bracket this time, taking advantage of how the software already knows where the entire bracket is, so we can line up the board pretty accurately. Parts on the bottom, and let's just do the holes first since we've already got that tool in here, and that might be more time for me to do playing with Tuco and or eating sandwich. So 0.55 still, which seems fine. It might have been rubbing a tiny bit still, but I think it came out alright still, so I'm fine with 0.55. And just the holes with the 1/64th. Oh, Tuco's even still kind of in frame. Oh, I was just looking at the chat from US Water Rockets. Does anyone else get annoyed that the Othermill sounds like a Hobby King quad rotor when the ESC beeps? I haven't had that specific experience because I don't have a Hobby King quad, but it definitely has that like generic ESC kind of sound. I don't have an Othermill Pro, but I think it probably sounds different since I don't think they're using a hobby motor ESC kind of thing for that anymore. I know they're using like a fancy custom design motor for the Othermill Pro, and I think they're using a different ESC, but I don't remember that part for sure. But yeah, this particular Othermill, the non-pro version, is actually just using like the same kind of outrunner motor you'd find in a big quadcopter to run its spindle. I've already had to have one replacement, but it was pretty easy for them to do, and they didn't charge me for it. And I think that was mostly because I was milling tons of FR1 with this thing, and it was before I had the compressed air, so I couldn't really clean it out as well as I do now. So I think I just ended up somehow getting like huge amounts of FR1 powder just into the bearing of the motor, and that killed it. So don't do that, kids. But Other than that, it's been super reliable. Actually, I don't even think that was the motor's fault. I think that was the bearing in the actual spindle that seized up. And I think they have new seals on that now, so this was just a problem that I hit because I was a pretty early adopter of this model. And then I think I just got a motor replacement while I was there because it was looking kind of old as well or something. Maybe they just felt like upgrading it, or replacing it with the same model at least. Othermill is kind of a local company here. They used to be in San Francisco. I've seen their shop a couple of times because I used to have a friend that worked there. And more recently they're in Berkeley, and I've seen their shop there too. It's actually it's really nice. But that was not because I had a friend there. That was because of the trip that I took to get my spindle fixed. I got to see their whole manufacturing setup, where they used to do, I think, all the cutting in-house, and I think now they're outsourcing a lot of that, but they have some nice assembly and testing stations in-house still. Oh, little stream dropouts, apparently. Well, since this is a bit of a low moment, let me see if I can just restart OBS again, just in case that helps. And won't disrupt all the recorders I have going. Be right back. Alright, and we're back. Hopefully that was only the minorest of dropouts. Tuco's awake now. I mean, more awake than he was. YouTube seems to like the stream better, but maybe it just hasn't had a chance to fall behind yet. Alright, I think another headset-free bite of my sandwich while this is doing its 1/64th inch end mill thing. Oh, I just saw a question in chat from Kenneth where I'm actually storing all this video. And yeah, there's a lot of video. Currently I'm using a 8 terabyte RAID 1 that I have attached to my Mac that I do my editing on. So all these other things either record locally or stream video to that machine. Hey, Tuco. Tuco. I guess I can move Tuco cam since he seems to want to come back in this direction. Focus. This camera easily has the buggiest autofocus of anything I've used recently. I got a bunch of these little carpet squares a while ago for the warehouse, and Tuco really likes them. I mean, I got them mostly for him. I like him too, but he seems to get the most use out of them. Hey, boy. All right, the longest milling is done. Looks like we're ready to switch to the other tool and cut us some traces. Do we still have audio? I'm realizing I can't see the VU meter. Yeah, looks like we still have audio. Yay. Alright, well, I will go do another tool change. I guess I can go back to head settings since I'm done munching on my sandwich and feeding Tuco. Alright, more headset. Alright, so back to the 80-degree engraving tool and the settings for that. So it's still got our trace depth. I want to pick traces and not holes. And then our placement for Z, we want this to be 0.15. That's what we were just using on the other side of the board. So I think that's right. Z 0.15, traces bottom side, right bracket. Seems good, it's just annoyed that I have the window open. I've always got to do this dance where I put the window on, and then I tell it to start, and then it tells me to change the tool, which involves taking the window off. Man, Tuco's probably out there with his bowl full of salmon chunks right now. Yeah, he and I have very different ideas about what food is, but he seems to like those salmon chunks. Yeah, and this is also a great opportunity for failure, because if this cuts too deep, then you have to kind of scrap the whole board and try again. But using the same parameters as before should be fine. I'm really impressed with how long these 80-degree tools, or at least this tool, has been lasting so far. I don't think I've had to, I don't think I've dulled it. Because every time you cut on it, you know, you're using kind of a different part of the tool depending on how wide the trace is. I still think the very tip would be pretty delicate. But you're only using the very, very tip if you're cutting a detail that's... Oh! That isn't good. Huh. I think the bit fan didn't quite have enough material to grab onto. Let's try that again. That's why the emergency stop button's pretty awesome. Because yeah, that totally could have just started shredding the bit fan. So I think I just pushed the tool too far up into the collet, and it didn't give the fan enough of the tool's shank to grab onto, so I just need to bring that a little farther down. So I just need to do a tool change. Change it from the 80 degree back to the 80 degree inserted correctly. Yeah, so that gets pushed further in and then into there. Okay, that is sticking out much farther. That's a proud little tool. 80 degree engraving. Okay, that's right, that was just the tool change. Alright, yeah, start milling. I think everything is still set up just fine. Let's just have the tool stay on this time. That was so satisfying to watch. I was worried it was going too deep at first, and it might have actually... I think it might have actually gone deeper than it's supposed to, but these traces are thick enough that it doesn't matter that much. And I think it's only by a very, very small amount. But we'll take a closer look at this under the microscope. From here, it looks great, though. We just need to cut it out. So for that, good old 32nd inch end mill, big chompy tool. Just the outline. And cut all the way down to z equals 0. Which will cut through the tape too. You know, I wonder if this would be slightly more convenient if we didn't cut entirely all the way through the tape. Maybe we can bump this up by like 0.04 millimeters. I don't know if that'll make much of a difference, but let's try it. Anyway. Let's mill that out. There's that feeling of panic when you see your 1/64th inch end mill back in the case without its protective cover. Where did I put that cover? It's probably under something. Well, here's a cover for a different tool that will probably fit. It's tempting to use a 1/16th inch tool for this. You know, maybe I will. Just for fun, because that would be fun, right? Oh, I've already started the job and it wants a 1/32. Fine. Othermill software not allowing me to be quite as spontaneous. That's fine. A 1/32 is probably the right tool for this job. Let's try to not... Now I'm like worried about that same problem before where the fan kind of rides down on the tool, and so it causes me to push the tool in farther than it should. Let's make sure we don't do that. I mean, you don't want the tool to have tons of extra shank because then it'll unnecessarily vibrate, but you also want the fan to stay on if that's a thing that you're using. And it seems to help. It pretty much eliminates the swarf right in the area where you're cutting, and because the box is enclosed, it mostly just ends up elsewhere where it's easy to vacuum. chompy is not the sharpest tool in there anymore. A little bit more gunk on the edges than I would normally expect, but I think there might also just be like some glue in here. Maybe that's from the tape. Alright, that's fine. Yay. Well, before I take that out, I am going to do the compressed air and vacuum on this. And I'm going to put on my hearing protection and turn off your microphone so neither of us have to hear that part. I figured you didn't want to hear the air compressor refill either. Alright, let's try to carefully get this out. Yeah, it's looking like that last pass actually could have been a little higher than 0.15, but this is totally gonna do. It just made the annular rings on some of the vias a little small. You have to be pretty careful getting the board out, especially when it's this small, because FR1 is not that strong. Great. There's our cute little board thing. I will leave the tape in here and take the other thing to the microscope where we can take a close look. Alright. On the way back, I'm also going to switch the recorders around because I can stop the recorder for these two machines and start the one for the microscope, because that's what we're going to be using next. Whoops. It's very tempting to sand this while I'm still in here, but I'm going to do that under the other camera where there's light, just so I can show that. You know, it's really nice to be able to show the piece like straight out of the machine, even if there's post-processing that would just be like a no-brainer to do right away. It's just always nice to show people right, you know, just exactly what the machine does. Nothing more, nothing less. Alright. I think I've got everything I need out of here. Hey Tuco, how is it out here? Hey, little guy. What do you think? Meow. Let's switch channels, little guy. Let's go... That's not got keyboard focus. What a terrible thing. Meow. Hi. I think this is what we want right now. Hey, Tuco. Does Tuco want to play right now? Which one of these is the kind you like, little guy? Is it this one? Oh, I haven't thrown it yet. I was going to adjust the camera. Alright. Recorders, yes. Let's do that. Oh, and let's make sure the backup is paused again. Alright. Shutting off the computer recorder and the mill recorder for now. Opening the microscope recorder. These are all just different programs I have running on different computers. There's like a Windows machine that I have running OBS to capture the microscope, and then the same beefy Mac that I have running the audio is also capturing the kind of HDMI multiplexer that I have a bunch of this other stuff plugged into, and it's capturing the mill over the network. And the machine, the mill camera is just like a little USB board camera from eBay with, it's like some kind of Freescale IMX single board computer with Linux running MJPEG streamer. Hey, Tuco, what kind of mood are you in? He's just sitting next to this box. I don't know whether he knows it's related to playing Bolt. I think I'm also going to be done with this headset since we've got this mic now. I can dispense with this thing's kind of harsh audio. Hey, Tuco. Hey, Tuke. Do you just want to play? Is that what this is about? He so wants to play. Alright. Cat wants to play all the time. Oh, Tuco's got a good problem to occupy him now. Great. All right. Tea and cat. Some of the best things. Okay. Let's not put that there. Hey, Tuco. I didn't intend that tea to be for you. I just figured that was a safe place for it. But I see you get a bolt. Alright, I just had these on my desk because I was photographing them right before this. I keep kind of wanting to set up like a little web shop where I can sell bits of physical art, because there's a few things like this that I would do, like little plastic things and prints and electronic things. I just feel like I haven't quite reached critical mass to open something like that yet. Oh, this is right off the mill. So this is the back side. This is the one that I think we might have cut a little bit too deeply. So the spaces here are maybe slightly wider than they're supposed to be, but they're totally usable. And then the other side, I think, came out just right. So I'm just going to first quickly sand the edges because they're a little rough and I just want to make this board a little easier to handle. But then I think the very next step is to do the vias, because this board we're going to need to take care to do the flat vias, since it has at least a few vias under the chip and under the USB socket that we'll need to keep pretty flat. Wow. Oh, Tuco, you're right here on the chair and you're rubbing me. You're such an affectionate little tiger. Do you want to hang out or do you want to play? I think Tuco wants to play. Oh, what is your bolt, little guy? Most of these are not the kind you like. But here's one. Did you hear that noise he makes? He's such a... He makes the best sounds. He is such a chirp cat. Oh yeah. I should totally make some of these that, oh, actually, let me bring a point of comparison over. Hey, Tuco. So, yeah, so these were just 3D printed. And then, oh, I should hit this with the UV flashlight because I forgot to mention, but the green parts, they're that polymer clay, whatever it's called, Sculpey. But it's, I mixed it with UV pigments, like what you'd find inside a highlighter marker. And I mixed a couple different colors and made this swirl. Let me hit this with the UV flashlight. Hey Tuco, this is not for eyes. It's already so bright. Let me show you with the overhead lights off. Am I going to need to go to manual exposure for this? Oh, maybe I need to turn this light off. Okay, that looks great in person, but the camera is totally failing to capture it. Manual. Yeah. Yeah, anyway, these are fun. I don't know what to do with them, but I decided to make these glow in ultraviolet light pretty strongly. Let me switch this back to slightly more automatic. Focus, all right. Anyway, I was mostly just going to compare that against these, which I made using the mill, the same other mill that we were just using. And for magnets, this is super great because I can easily mill the other side and make these pockets that are just barely big enough to fit a neodymium magnet, and then I super glue it in there. So, and this has a little etched Tuco design on the front. And then this was the first one I made with this process, I think. I think the second one came out a little better. The colors are not quite as contrasting, but the milling quality is a lot better. Can I get closer? Anyway, maybe I'll put these under the microscope too while we have that out, just for fun. This also has magnets in the back. So these, I think these will actually stick to my work table here. Yeah. So yeah, I made these as like whiteboard magnets for documents and stuff. I also think I would totally sell these as cat magnets, since, you know, gotta have a cat magnet. Anyway. Let's get the, well, let me do the sanding first, just to make this easier to handle, and then we can look at that under the microscope. Oh, it looks like Tuco is back on the chair, so. Oh yeah, we've got our favorite chairs again. Good little tiger. Did I speak too soon? Alright, so I'm just going to do the edges. This is great if you think you have any OCD tendencies. You can just start sanding things in a regular pattern. It's totally a thing you can do that's socially acceptable, right? Alright, that makes this much easier to work with. And I'm not going to worry about sanding the front surface at all because I'm going to put the vias on and then sand as much as I can on something flatter than this sponge. Alright. Take that out first. It really does not have a lot of structure visible. I mean, you can kind of see, I think the putty might have some like grains of mineral stuff in it, or maybe those are just leftover bits of the pigment that didn't, that weren't powdered as small as the rest. I don't know. And you get a little bit of texture from the 3D print, but it ends up being a lot more uniform than I think I expected going in. Cat magnet number 1 versus cat magnet number 2. This one came out a lot better. Kitty. I think I just colored this one with like a Sharpie. I guess there's a little bit of stain on the front that I could probably get off easily. And so this was the same machine, but I made the tool path using a commercial program. I made this with vCarve. So I started out with an SVG from an Illustrator drawing that I drew on a tablet, and then turned that into a tool path with vcut. And then this material is just a square of Corian. It's a kitchen countertop material, but I got like a bulk box of color sample tiles from eBay, which were already cut into a nice small size to work with in the mill. So, and then glue, CA glue. All right, let's start doing more electronics. I was laughing at the comment from K. Timken. You call them cat magnets, but I've yet to see them attract a single cat. See, but I like the meaning for the same reason, but I guess I tend to think of them as symbolizing my own ability to attract cats, rather than necessarily themselves having that ability. Yeah, if I did have an actual cat magnet, then it would probably attract quite a few cats around here. A lot of my neighbors have cats, and there are at least a few that live outside. And my neighbor Wendy is a pretty awesome kind of cat person, and she takes care of my cat and takes care of neighborhood cats. But then there are some cats that just like to hang out outside and don't really seem to want to be indoor cats. And she tries to take care of them, but you know, there's only so much you can do for a cat that wants to be outside. Yeah, so I think my 1/32 inch, well, so some of these vias are a little bit, like this edge on the inside is not so great. I think that's because I was letting my 1/64 inch tool touch the surface a little bit. Once I changed that parameter, I think some of these ended up better. And on the other side, I don't see that problem at all. The rings on these vias are pretty small, because I think the whole board should have been cut with a slightly higher Z height, but still totally usable. So, step one, let's put some wires in those vias to make them conductive. Hey, Tiger. All right, I don't think it matters which side I start with. And I guess theoretically the side on top is maybe a little more likely to be damaged during this process if I mess up something. Okay. I'm going to try to get this camera framed a little better. Okay, that's going cool. And so last time I was using 26 gauge wire. I think the via sizes look similar, but let's check that out. You could also try using smaller wire and see if that helps. I've also got 30, which is insulated but is easy to strip. Everything I have that's smaller than 30 gauge is difficult to strip because it's enamel coated. So let's see how this compares to the vias sizes we have available. Let's also have more light. Yeah, sure. This light needs adjustment. Don't want the shadows to be quite so amazingly severe. I think they're even more severe now. Maybe just further back in general. I also still have the microscope tilted quite a bit, which is kind of handy. It might just be annoying. I might decrease the tilt severity slightly. Has the knobs in all the most convenient places. That's looking better. Oh, the cat's pretty chill for a change of pace. Oh, that's plenty big. Actually, I think I can just put that in by hand without using the tweezers instead of the pliers, which is good. Yeah, that's great. Let's see how fast that makes this job. Yeah, unless I keep those wires longer, they're just going to fall straight through. I could put the board on something that's less tall, but that would make the soldering less convenient, so I think I'm just going to use longer wires. Let's try this gun. And let's maybe actually just do these in order, since I think this method might actually work. Yeah, that's much faster so far. And so, yeah, we could cut a little more wire. If this was a bigger board, I'd be tempted to do a batch and then use the extra leftovers in some other kind of jig, but I think at this point, for this kind of prototype, I should probably optimize for fast assembly rather than absolute minimal use of wire. Also occurs to me that maybe something that, I don't know, it's useful to have it spaced off a little bit, because like I've tried soldering via wires with the boards just taped directly down to glass, and there just isn't enough space to form. They're like, I think the problem is if you have the, well, there are a couple of problems. One is if it's directly touching the glass, then that acts as a pretty good heatsink. But I think the most pressing problem in this particular case was that yeah, I think I just wasn't, I didn't leave enough wire below the hole with that method. And so it wasn't really possible to make a good solder joint on that, on the opposite side. Oh, that was a little off frame. I try to do at least a couple of these with my hands not covering up the entire picture. It's been a bit of a balancing act between how do I find out just how to do this the most efficient way, and how do I get it on video clearly. Alright, this is almost done. Just solder these into place and then make them flat. As flat as we can. I think that's all the vias. Cool. Just trim the one that's super long on this side and then do some soldering. I'm glad we didn't have to go through some kind of terrible Eagle file compatibility nightmare. I think I had just gotten the Othermill software earlier into some kind of state where I needed to reset it, and then it was able to load the Eagle file again. Don't know what was up with the Gerbers, but I think the Eagle file might have just been some coordinate system issue. I think someone commented on the last stream that it sounded like there was a boiler or something in the room. I'm sitting right next to this gas heater, and right now it's making this noise that I think it's just the metalwork inside contracting slowly after it turns off. Because it's pretty quiet when it's on. I think the cycling can cause it too. Ooh, this whole situation might just want a lot of flux. You know, I might just use the syringe for this. I think these homemade boards always end up not having enough flux. So let's not have a cat hair on the syringe. Maybe that's not a cat hair. I think it's a cat hair. Make sure we have plenty of flux on all these vias. Ah, that's nice. The solder just forms a nice circle. Yeah. Oh, that's so nice. Yeah, that's an improvement. I mean, I think I'm going to need more solder total because more of it's going to flow away from the via, but it does seem to do a much better job at having a clean flow go on here. And I feel like it's only recently with, with GitHub and just sharing hardware designs on the internet becoming kind of more common in general. Like, I think it's only then that I put a lot more value on like having a really solid design out there that a lot of people could assemble. Whereas before, I was a lot more content to just do a one-off prototype with crazy wires that no one could possibly ever replicate. Whereas I think now I've got more motivation to make stuff that's easy for people to just like fork and modify. And so it's nice to have the ability to prototype something that's just someone else's design that, someone that is like in your community, but that you don't have to physically be close to. They just I think there's a lot of, I don't know, like a lot of this is just like building blocks, like open source hardware in a lot of cases doesn't necessarily look much different from the reference designs from the parts you look at, which you could say for a lot of commercial hardware too. And so sometimes the open source hardware is just a vehicle to get the open source hardware running. But then sometimes you see hardware that has a lot of cleverness built in. Oh, that was a little too much solder removed. I had forgotten whether that was just like a peak in a bunch of extra solder that I left there, or whether that was actually a wire that needed filling. I think for a long time, like, I worked on both hardware and software, but I guess I saw software as something that was easy for me to share, and hardware as something that I just did on my own and just was kind of content to do on my own. I didn't really ever kind of feel like I had a way to share it or a need to. I mean, I would eventually post like pictures and stuff, but it was still a while until I started making designs that were actually easy for people to replicate, or at least, where I tried to. I feel like I've still had a lot of failures in that regard. Like a while ago I did this, project to do like this reverse engineered sex toy thing, and it was something that I think I wanted a lot of people to be able to, like, especially women who want to have their own like open source remote control vibrator kind of experience. And I wanted to make that kind of thing easy to program, just like with an Arduino. And so I had this like remote control that you could build using like a Nordic radio, or not a Nordic, but like a Chipcon radio or something like that. And then it would send signals to this like existing commercial vibrator that you could get. And so, I don't know, it was an interesting project for a lot of reasons, and I think it might have inspired people still, but it didn't end up being as easy to replicate as I'd hoped, because like some of the parts that I used, I hadn't realized it at the time, but they were obsolete already. Like I used some old SparkFun LED display module that I had handy, which was great, but they had already discontinued that model. And so I tried making a firmware that was compatible with a different one, but it was like a very big departure in approaches, and like I tried to use one microcontroller for something that was previously using two, and so that version of the firmware, which I tried to make easier for people to use, actually wasn't as good. And then I also tried making one with a cheaper sonar sensor, because there were these, like, I think it's called HCSR04. I think I ended up talking about these in that sonar video I did much later. But like I tried making a version compatible with those because they're so much cheaper than the parallax sensors, but they're also just not nearly as good. And so, you know, I feel like my attempts to make a version of it that were easier to replicate and cheaper just kind of fell flat. But maybe the part that was actually important was just putting the idea out there. I would get emails from people who wanted me to build them one. But, you know, the thing was, it was typically not emails from people who wanted one. It was typically emails from people who wanted to like, have one to present to their partner in some kind of way that, I don't know, it's like, it felt like it was kind of missing the point of, like, empowering people to own their own, like, sexuality in this particular way. So, you know, I mean, I certainly thought it was fun to make stuff that you could use with other people, but it was also like kind of empowering to have something you could use by yourself. And I mean, I think this was pretty much something that fit pretty solidly into both of those categories. Certainly have some X's that I used it with ages ago, but that was a long time ago. Got stuff all over my cutters. Flux is great, but it's so messy. Tuco. This does a pretty good job of cutting these flat, and especially thanks to the flux, these seem to have flowed quite nicely. And got a nice sturdy connection. I often use too little flux when I'm doing stuff that isn't surface mount, because I'm like, this doesn't need it, but it helps so much. I will clean this, but I think it'll be easier to clean once it has things not poking out of it, you know? Oh, I don't want to be cutting stuff while I have Gook in the tool. That's a recipe for making things wrench off of the board. These are probably as trimmed as I'm going to get them with that tool. I think let's do a bit of an alcohol wash on that side and then solder the other side. I mean, yeah. It's tempting to not wash it yet, but I think I'm going to want to sand it after doing all the vias and before doing anything else, and sanding it while it's covered in flux will be messy. There's a question in the chat about whether I'm using 2331ZX flux, and apparently I am. K. Timken says for the flux inside the solder for the 2331XZ doesn't flow to the board as well as e.g. RMA fluxes. Oh, and another question about the dilution of alcohol. This is 99%. Which seems like it's usually best for electronics because you don't really want water. This can be a little easier to get 70%, which is probably fine if you don't have anything else, but I think the higher concentrations, like it's a trade-off. You want the higher concentrations for electronics because you don't want the water present to cause corrosion, but certain kinds of messes will just never clean up with 99% isopropyl because you need something that's, I think it's polar or non-polar, I don't know. I'm not a chemist, but it's one of those. And so, yeah, sometimes if I've got a mess like that, I'll squirt it with the isopropyl and with the water, but usually I just want the isopropyl. Alright, so that side I think is fine other than the sanding. And that's about the height we're getting right now just with soldering, so like that is kind of too big of a solder ball, but it'll sand down really easily. The main thing you have to be careful about with the sanding is it's really easy to wear down the edges of the boards, so I might try putting some Kapton on the edges to protect them. I haven't tried that before, but I think it might help. But first thing, let's flux and solder on this side. Oh, and I think the kind of alcohol slash other solvent that you use to clean up will definitely depend on the kind of flux you use. I don't remember what kind of flux this was, but I had some flux that it's just like really, really old. And I was doing this project, and yeah, I just made this huge mess because I had just gotten myself in the situation where I had this big, it was like an art project with a bunch of FR1 boards that were glued down to some plywood, and so it was this big thing that was kind of hard to disassemble once it was all put together, and so I was doing various, kind of cleaning and painting and soldering in different stages and trying to keep it pretty clean, and then there was some chemical I used, and I'm actually forgetting whether it was flux or flux remover. It might have been one of those like old lady who swallowed the fly or swallowed the spider kind of situations where I have the flux, and then I use the flux remover, and then I have to remove the flux remover, and then so somewhere along the way, I had some mess, which was probably mostly flux at the time, and I tried to remove it using isopropyl, and it just made it super worse. Like, it just turned it into some kind of like half glue, half precipitate, particulate gunk. It was just terrible. I ended up having to, I think that was what I was using the flux remover for. I think that was like flux that does not come off with regular IPA, and then the flux remover ended up being necessary, and then I also had to remove the mess that the IPA had turned the flux into. It was really gross. I don't want to do that again. this flux seems to clean off really nicely with isopropyl. All right, that should be enough to get it in all the right places, I think. Maybe a little more over here. Try to stop it from flowing all over the place. Hey Tuco, what you looking at? That was half-hearted. I think I'm just wicking most of the solder onto this other pad. And if there's anything that conducts heat well from the soldering iron, it sure is solder wick. Pretty great way to burn your fingers. Oops. That is a bunch of solder that is not ending up where I wanted it. Hair in the flux. Glad you don't have smell-o-vision. Let's tidy this up a little bit. Okay, I think I've cleaned up the little spill here, but I need to add some more to these vias. Ah, think that's better. Light angles can get pretty tricky on this. I feel like I maybe should solder both sides before clipping either, because I can feel these moving a little bit, and I'm going to have to double check the other side to make sure that they have a good shape still. So that's maybe a slight change to the procedure for next time. There's some comments in chat about 100% ISO. I don't know where to get 100%. That seems like an expensive object to have 100% anything. I mean, I think this is actually probably 99.9 or 99.5 or something like that. I think I just only felt like labeling it 99 when I had the label maker in my hand. Oops. Too much solder between the pads and not enough on the wire. I think not enough heat on the wire is the problem there. I put on too much solder without giving the heat enough time to make it up to the wire. That's better. All right. So I'm going to solder all of the vias on this side, but before I cut any of these, I'd like to check the other side to make sure they're all still long enough, because then, then I can just push them in a little farther. I don't have to redo the via. I wonder what this is. Are these... I don't know this PCB design well enough to actually know what all these parts are, because below this is definitely a USB socket, but then I assume these are passives of some sort, but maybe there are test points. They're a little bit strange shaped to be passives. That's going to need some cleanup. Okay. That looks fine for under the chip. Oh, is that the last one? I think that's the last one. Let's check the other side. Actually, it might be worth cleaning the flux. Let's check the other side anyway. And then clean the flux. Oh yeah, there's some that we might want to touch up. Yeah, should have done the trimming after the second side soldering. Alright. That seems fine. No big problems there, but a couple of things that were nice to touch up. Okay, so cleaning and trimming the other side, I think, and then sanding. Ooh, it's already sticky. Let's do a bit of a flush with ISO and then clean out this forest. Timber. Flux is a great way to just make everything sticky, in case you're looking for a way to make everything sticky. I like how there are these huge things that you can barely see under the microscope because they're pointing straight at the lens. Speaking of lens, can we get a better angle on the DSLR maybe? we can focus that close. Okay. Isopropanol. Ooh, such isopropanol necessary for this. I should be using a wipe for this instead of a Q-tip. Science! These are science tissues. Yeah, that's pretty good. Pretty absorbent for science. Take care of some of that abrasiveness with the sandpaper. Let's clean the other side, and then I mentioned I wanted to try protecting the edges with some Kapton. I think I'm actually going to do that. I think we already cleaned the other side, but there might be a little bit of flux. Yeah, there's still some flux, but and some tissue now. All right, we'll take this to the sanding, and that should make short work of this. Can we make these any less sharp before sanding, maybe? Very slightly. Now, I think some of these settled since soldering. They're not quite as trimmed as they could have been. That's fine. Okay, let's dry this off a little bit, and then I'm going to put some Kapton tape on the edges to try to, you know, I think maybe, yeah, I think Kapton tape's enough. I was thinking about doing something more complicated with putting some scrap PCBs on either side before sanding, but I think the Kapton will be enough to at least have the edge of the copper not be the closest thing to the sanding surface. So I think that'll be enough protection. I think I've got some little Kapton here. It also doesn't have to be Kapton. I think I've got painter's tape here too. Well, there's my Kapton. So I think I can be pretty, I can put this on fairly roughly because all the pointy vias are going to poke through this anyway. So I don't think I really need to worry about like only protecting the very, very edges. fact, this might be handy for some of the... Yeah, let's try this. Never done this quite like this before, but seems like it might work. So I'm just going to cover both sides with Kapton and then assume that the Kapton, like right around the vias, will wear away quite fast once I start sanding. But that the Kapton on the edges will protect that part of the circuit board. Let's see if this works. Okay, so I've got this thing now that's just kind of a sandwich in Kapton, not really carefully put on, but just kind of as a protective coating for the lower areas. And it's still very pointy on the vias that we just put in. So I have a piece of sandpaper that's taped to a board for this. Just a sanding disc and a piece of wood. So let's do the back side first because it's a lot less critical. I'm going to try to be holding it flat and just rubbing the protruding pointy bits against the sandpaper. It's getting flatter rapidly. Kapton seems to be doing what I want. It's protecting the edges of the copper from getting scraped up, but it's letting all the vias through. Alright, I'm going to do a little more of this just for practice, but this side doesn't need super flat vias since it doesn't have any chips, just the other side. But I'm just going to try out this technique a little bit more before I do the really critical one. There's some bit of abrasive that I think came off here. Oh, here we go. I think there was a bit of loose solder that came loose and was rolling around. Let's look at that on the microscope. So we can see most of that is doing just what we wanted. I think that little bit of, here's something to point with. Yeah, I think it came out like right there. That's, what is that? I think that's conductive debris, our old nemesis. Thanks, conductive debris. Alright, I don't think that came off of the board. I think that was just hanging out in the vicinity. Three files. Manual focus. That's looking good. Do a quick microscope inspection and I think flip it over. So, needs cleaning of course, but I think the depth is looking good. This area over here is a little weird. I might poke at that with the tweezers to see what's going on there, but I think that's just the tape. I think the rest of this looks about good. So, and then this side is still untouched. Until now. Let's sand that a little. So far, so good. No, it's comfortable now, but I think for the chips on the top side, I want this to be a little flatter still. So let's keep going. Getting a nice little cross-section of the vias. We'll take a look under the microscope shortly. Still want the area under the chip to be a little less pointy. Tuco. He doesn't seem to mind the noise. I don't want to push my luck, but I think I can go a little further without it being a problem. The flatter I make this, the less annoying it's going to be to put the chip on. Okay, I think that'll be fine. I mean, it's kind of a compromise between how much you want to fiddle around with getting the vias just right and how much you want to worry about putting on the chip, even though there are giant annoying vias under it. But it seems reasonable. And if we peel this off, we should have our fairly protected board underneath. Probably should have done this wearing gloves. I've got solder dust all over my hands, which I should go wash off. There's our DIY flat vias. I'm going to wash up and put this away, and then we can look at it under the microscope. How's the stream doing? The YouTube's saying that our video output's still a little low, but... Alright. So that's what we got. A little bit of kind of gunk in between there, it looks like. Nice. All right. Well, I think this is you think this is a good time to end it, or do you think this is a good time to keep going? Feeling like I could go either way. We're hitting almost, what is it, almost 4 hours here. But we've got all the hard parts out of the way, really. I mean, I guess the next hardest part is just mounting the Maxim chip, and then just a handful of passives and stuff. But this is also just approaching one of those points where the stream is already pretty long, and this is looking like a fairly natural stopping point where this is basically a manufactured board now, and we're ready to just mount stuff on it, pretty much like we would with a board that we ordered out for, but with a little bit more care because of the not quite flat vias we've got. Oh man, we got a bunch of enthusiasm in the chat to keep going, so All right, let's do it. I'm going to take a quick restroom break and refill my water, but let me make sure Tuco cam is adjusted, and we will get back to this and put the chip on. I wonder if I can put this any higher while Tuco is hanging out right here. No, that's just too far away. I think that's an improvement. Right. I'm going to pull this design back up on the computer so I know what to put where. All right. answer. I guess I should have this recorder going if I'm using it. Oh, I have this idea for a project. Because I've got all these controls that I need for streaming, for like switching channels and starting and stopping recordings of stuff. And right now I've been using this little Bluetooth presentation clicker, which is better than nothing, but it has some issues. Part of it is just the Bluetooth, I think. It has a bit of a lag when it goes to sleep. It kind of takes a sec to wake up before it registers the first key press. But the most serious problem is just that I don't have very many buttons to choose from. It's actually kind of nice for a presentation clicker. It's got like a thing where you make that bigger. So it's actually got a little drawer where you get a few more buttons, which is nice. But you can't really program any buttons that work as kind of system-wide shortcuts. You know, you actually get like play, pause, that kind of stuff, but I don't think you can hotkey those in Open Broadcaster, which is what I'm using. And everything else just kind of acts as stuff like arrow keys or arrow keys plus control or number keys, where it doesn't really work unless I've got keyboard focus in the right place anyway. So anyway, my idea for a replacement for that would be something that kind of magnetically attaches to these posts, these like light stands that I have around the shop. So I've got these like vertical posts. Just got a view here. So like this one that this light is attached to, and this microphone, and the one that this camera is attached to. Hello, camera mount. So, for example, if I could like have something that magnetically attached right here and like wrapped around even, and had a sequence of buttons on it, and then had USB preferably, because wireless I assume is either going to be laggy or need batteries changed a lot, so wired is probably better. And so I was imagining actually I could probably make a pretty nice kind of assembly demo out of that also if I made something that was flexible. So like I'm imagining like a 3D printed case designed to fit, like I'm imagining designing something so that, you know, it has the right shape when I put my hand up to it, but then unwrapping that from the pole and thinking about, you know, how that looks in 2D, and then building that out of flexible materials. So I think that could be a pretty cool upcoming video, and that would be something that would give me material for the fabrication video that I'm working on, since it would be like Pyrolux and milling and assembly, and then it would also just be an interesting project on its own. And I think the microcontroller in there could probably be like an ATtiny85, or, I mean, I could use an off-the-shelf board like a Teensy. A Teensy would be great for this, but it would be nice to use a bare chip just to make it smaller, not have an entire board on there, since I think it could actually be a pretty thin product kind of thing where, you know, you just have like really just a sandwich of flexible printed components and a flexible circuit board that has really thin tactile switches on it, and then the flexible case could be made in a way that has more rigid components to act as buttons. So that'd also be a nice modeling project. One of the technical hurdles I have between, you know, where my setup is right now and where it would be easy to stream that is I don't really have a good way to stream CAD stuff. I mean, this computer I have set up for streaming right now is great. I could run Fusion 360 on it. I've been doing most of my CAD with Rhino, and so I guess part of the question is, like, do I do videos with Rhino, which I like and I know but is expensive, or do I do videos with Fusion 360, which I don't like as much but is something that is easy for anybody to use? And I mean, I think the answer is to do that with Fusion 360, which means I can I can just use this computer, because I don't need the computer that's like hardware licensed for my copy of Rhino. That was a tangent. Let's, if I remember where I put the remote back, let's go back to the computer with the EagleCAD files. Okay, so here's the schematic. I think what we actually want is the PCB layout right now, since I want to know what goes where and how it should be arranged. So is this the right side we're looking at? Yeah, this is the top side. We don't have any of the labels that this is supposed to have. Pin 1 is hard to see. I think that's pin 1. Oh man, let's turn some of these layers down. There's too much going on right now. Let's not even look at the back, because I don't think there are any components on the back, right? I mean, there's a spot for a USB port on the back. I don't think I still think I don't have that USB port, the Type A host. I don't think I have a surface mount version of that handy. I could steal it from something else if I cared, but I think I might just leave that unpopulated since I don't need it for this experiment. I just need the two USB, well, the one USB mini on top. So yeah, no parts on the bottom I care about. Let's just turn off the bottom. And that crosshair must be the pin 1 for the microcontroller, but I'm going to have to check the pin numbers. That is much harder to read than I would have liked. I don't see the pin 1 dot. Oh, that's the pin 1 dot. It just looks a lot like a VIA. Okay. It was just looking right at me. Be great if I could rotate this, but I guess I won't. I guess I'll rotate the board. All right. This is nice. We've got our parts. So this, yeah, you can see on the back here, there's this large outline of a USB jack. That's the one we're not using. And you can't see its data pads because they're surface mount on the back. And then those are just vias. Yeah. But then this is the USB mini we are using. So this is another area where it's important for the board to be fairly flat. Like, this is going to want to have a connector right on top of it. And then that is a jumper, which I think we don't need to worry about populating that either. I think that is just for USB power, if we care. And I don't think I care about USB power. It's just there in case you want it. I mean, I could stick some 0.1 headers on it just because that's convenient, but it's not really necessary. I'll put all the headers on after the surface mount stuff. So I guess it's just some passives and the chip. Oh, I can stop stalling. It's so easy to get distracted by how pretty things are in the microscope. All right, let's make those line up again. Just get some of that flux up on the left side here. Alright, so that's pretty much where it's going. I'm going to just start by tacking down something like this top left pin. That's Tuco cam. Alright. This soldering iron is filthy. Let's give that a good clean. It's tacked down just barely on that corner. I want to do something similar on the other side. Okay. So now it's kind of more mechanically stable, and we can just worry about getting enough solder on the pins without disturbing the vias under the chip too much. I'm going to start out by draining that puddle a little bit. I'm sure there will be more puddles, but they're not going to make things easier. Now, I need to make sure the DSLR is still recording. I don't actually have a DSLR viewfinder on that screen. That's better anyway. Alright. Now, to some extent, the combination of the flux and the surface tension is going to make this easier, but we're still going to have to be pretty careful about how much solder we put on there, because without a solder mask, it's easier to get bridges that are difficult to take away. So, I'm mostly going to be doing this motion where I'm kind of temporarily creating bridges, but then brushing them away. And I'll pick up those extra blobs of solder in a sec. You just have to be careful to dump them somewhere where they won't be in the way. Like, I don't want to dump them on top of these vias. Well, maybe now I have to. Alright. So it's hard to tell whether these actually have a good fillet because with the chip hovering a little bit, it's possible to end up with not enough solder. So we'll take a closer look with the microscope angled. After all the obvious problems are dealt with. I have to be really careful about reheating these vias that have been sanded because with so little surface area, it's really easy for them to get into a state where they just won't want to reattach. So we'll have to be a little careful about that via. Like, it's possible that might be suspect now, but I think it's fine. Let's see if I can get a better angle to pull the solder across these pins. Oops, I have bent a pin very slightly. I'm carefully bending it back with the iron. Bending another one carefully over here. Okay, I think we've got one more side and then the inspection. I'm going to make such a mess with this flux syringe. So looking at it quickly before angling the microscope anymore, or cleaning off the flux. These mostly look good. There's maybe one on this side I want to take another look at. Is that a no connect anyway, that third pin? It's probably connected under. Alright, that's definitely connected now. Okay, this is seeming fine so far. I think the next step is to clean it up a little bit and get rid of the extra solder and flux just so that it's easier to inspect it, and then to inspect it. That's satisfying. Don't think I'm going to suck that one up because I don't want to risk disturbing those two vias. I'll leave that one as is. I can get this puddle though. Sorry, Vice. Gotta get like aluminum jaws for this thing. Slurp. Good old slurping. Gotta slurp those puddles full of tasty lead and tin. None of that lead-free solder here. Completionist. Alright. So satisfying, especially when there's plenty of flux. But alright, time to end this flux party. I mean, I probably don't need to clean this super much because I'm about to put a bunch more parts on it, but there is a lot of flux on there. And honestly, I don't think these other parts are going to need a lot of flux for them to be easy to put on. So, let's raise the scope a bit. There's still too much flux on there. I'm going to flush it a little bit with the isopropanol. I mean, too much for this to be a clean photo is my criteria right here. It's certainly not too much for it to be an okay electronics project. It was just getting in the way of seeing some of the details that I wanted to see. So it might be worth doing a more thorough test with the voltmeter, since continuity lies a lot less often than visual inspection, but just looking to make sure there's a fillet in the area where the chip is kind of hovering will get us most of the way there. Like, that looks good. I think that's good. Yeah, it's definitely good. Yeah, it seems all right, but let's just do a continuity test for an extra measure of caution here. I think this will give me an excuse to use my favorite method of X-Acto knives and alligator clips. Circuit boards are always so fiddly with the lighting. All these shiny, ridiculously small components. Alright, I'll get a couple of knives. Alligators and knives, exactly what we needed. And a beeping thing. Any kind of beeping thing would do. My beeping thing is a Fluke 179. I really like this one. I've had this one for a long time. I mean, it's not like one of my oldest tools, but I think I got it in like 2005-ish or so. So some pointy things and some alligators and some beepy things. Most of my alligators are not very good, but they'll do. Yay. Oh, this lighting is terrible. This needs work. Let's see if that's better. This is a slightly dull X-Acto tip. I need to get it on the point here. Okay, that's fine. Okay, let's rotate. If you haven't seen them, you should definitely check out YouTube videos of robots doing exactly what I'm doing right now with little needles. Because they do it in factories all the time, and they're really good at it. I mean, usually they don't do it from chips to the board, but like for electrical testing of circuit boards that don't have chips on them yet. This is the last side, right? 4 sides. Okay, cool. this should be the side I started on. Just gonna do it once more, just I'm paranoid. I think this is the, yeah. Alright, cool. I'm satisfied with this chip. So I think we've just got to put on a handful of passives now. So, you know, and then some connectors and plug it into the Raspberry Pi and do some Python stuff maybe. Oh no, I'm getting flux all over everything. Let's make fewer flux messes. I don't think I'm going to need much of this at this point. Oh man, this USB cable has so many cat bite marks. Check that out. Tuco just wanted in there. I think he likes the way it feels in his teeth or something. He doesn't do this on most cables, but every once in a while he finds a tasty one. And I try to make sure that if there are any that are tasty and carrying power, that I coat them appropriately with something that he doesn't like. I usually use these like split loom tubing kind of things for that. Cat magnets. Alright. Circuit board layout. Alright. Cool. I think our microscope is zoomed in more than Eagle is. But maybe let's put on that crystal next. That looks juicy. I think really next is I grab my bucket of surface mount doodads that is likely to have these in it and put on whatever we find first. I know this looks a lot like the one that I said the other day was like the most disorganized one I have. It might be the same one, but I think I saw the parts for the face dancer on top of here. Oh, what speed is that? 12? I think that's this. No. Oh! This is using a different crystal package than the other face dancer. Now here's the connector we want. What else are we looking for? 18 picofarad. And some decoupling capacitors. Oh, those are jumpers. Oh! I guess that's what... Oh, never mind. I thought I saw some pads earlier that might have been test points or something, and I've previously had projects where like I'd used a jumper footprint and then I didn't have the right, like one of these shorting jumpers, but it didn't actually mill out the gap between them, so they looked like test points. But those look like they're milled out fine. So those are jumpers for optional features that we can leave clear for now. Those are resistors. That's a USB jack. That's a 1 microfarad capacitor, 0.1, 12 megahertz, and load capacitors for the crystal, so like 18 pico. So that should be pretty easy. I have these 12 megahertz crystals that are in a different package that we could try to use, but I think I've probably got something in that package that would work. Where's this? This is probably a 25, yeah. bunch of 32 kilohertz crystals. Some more capacitors. And 33 ohm. That's most of what we need. The crystal might be a little harder to find. Check my other locations for a 12 megahertz surface mount crystal. So, you know how there's that thing where I have to pull the crystal off of the thing that I want to synchronize with the chip whisperer? I think I have a couple of these 12 megahertz crystals that I removed from the Wacom tablets. And it's not the same package, but it might be a closer match than the other one I found. Like, I might be able to make it work. So it's something like that, and on the bottom, it looks like that. So I might be able to just mount this diagonally. Like it'll have to hover slightly, but I think that'll be better than mounting a much larger crystal in the same location. So we'll try that unless I find a better option. It'll probably be fine. I have this other crystal which I happen to pull off of something also, and this is in the same package, but these are 25 megahertz. Oh, let me check my hackable gadgets to see if there's anything I can desolder one from. It's the lowest grade hackable objects. These are things that are just like flat out broken. Big crystal. Ooh, what is that? 44 megahertz. Huh. Oh, is that a USB controller? No. Close, but... yeah, I think that's going to be the closest match. There's something that looked like the same kind of package, but it was like, I think like a radio filter. What is this? 30 megahertz. Also in that larger package though. $12, but in the larger package. Alright. I'm satisfied. Well, let's see if we can get that on, since that's likely to be the next trickiest thing here. Stucked. Okay. Let's try this to start out. More solder on the top left, a little less on the top or bottom right. And I'm going to try putting some solder balls on these pads. And let's see how bad that is. So my plan is basically, imagine this was upside down. Just like that. Okay, let's angle the microscope and then do that. Okay. Whoa, is that way too much? I think that's way too much. Well, yeah, that will not focus. Let's try that again. Maybe someday I will make a nicer microscope stand for this. How's that? I think that'll do. Okay, that'll tack it down. I was trying to mostly get it at the right height, and need to adjust it so the other contact is in a good position. Okay, that side's just temporarily tacked down while I solder the other side. Maybe for real, if it's in a good location. I think it might be too far down. Yeah, let's try that again. It's alright. Let's see if I can get into the other side to redo it. Yeah, that was what I was going for, I think. Okay. Crystal problem may be solved. There should really just be a gallery of like surface mount footprint error workarounds. I had a really bad one with one of my earliest projects. I think I mentioned it in an earlier stream, but it was like basically supposed to be, you know, like a really early like PDA kind of thing, like something you could type your schoolwork on in school. Yeah, it was like a very roundabout way to care about school. I did this embedded Linux thing with the 68000 running UC Linux, and I had totally the wrong footprint for the DRAM in the system, so I ran 30 gauge wire from all the DRAM pins to the board. And I'll have to find some pictures like that to scare people into double checking their footprints when they have a circuit board design. I get some light under this, maybe. Hovering crystal. Okay, so I think all the other parts should be pretty straightforward. That one looks fine. I'm just trying to, like, mostly what I'm looking for is bridges to any of the adjacent ground traces, but general mechanical stability, you know, is also important. This is technically the only moving part in the circuit. Alright. Let's go back to the Eagle. Alright, we mostly just have some capacitors and stuff, not much going on anyway. I think maybe the first parts I have handy are 33 ohm resistors, which go down here. So I've got two of those. So those go right down here next to the USB connector. That's inconveniently small for this board. Well, maybe I have to compromise here too. Huh. Alright. Let's try to attach that somehow. Yeah, I might end up looking for a larger resistor, but this would be less of a big deal if this board had solder mask, but I don't want this shorting to the plane underneath. is less of a demo about how to do resistors properly, though. Guess I'll have to do that elsewhere. This one will have to be one of the when things don't go quite as you intend moments. I think it's mostly the when you try to build something out of whatever you have handy moments. Because, you know, if I had bothered to order parts for this, then of course you check these things, but that looks a little bit crusty, but I don't want to necessarily risk having, well, let's put a little bit of flux on there, but I don't want it necessarily to flow too well, since that could be, you know, we'll see. Flux is usually helpful. Yeah. I think sometimes it's helpful to have solder that's like a little bit sticky when you're initially tacking things down, but then for the final joint, I think flux pretty much always makes things nicer. Alright. One more of those. Tinier than necessary 33 ohm resistors. There it is. Yeah. Why do I have these in 0603? No one will know. I mean, I guess I had most of these in 0603. Which, I don't know, I think most of the boards that I just kind of throw together don't need to be this small. But I guess I had 0603 versions of the Facedancer parts for some reason. Because this is from the batch of parts I got for assembling Facedancer related things. I think those are fine. Let's see what we have next. This is 0.1 microfarad, which I think we just have one over here, right under the crystal. These are also 0603. A single 0.1 microfarad capacitor. I think I really like using the microscope to demo pretty much all the soldering because most of it just looks so good under the microscope. I often worry about, well, it's I guess a question of how do you present the experience, like as it kind of feels versus kind of using the same equipment. Because I feel like looking at video of soldering under a microscope feels a lot more like actually soldering, even with the naked eye a lot of the time, because, you know, it's like your brain kind of zooms in on the details a lot more than most cameras would. but it means I often end up using this microscope for a lot of things that I wouldn't normally use the microscope for. You know, some things are even like a lot slower to do under the microscope than not. But it just makes such a nicer demo. I think that is actually super not, yeah, that needs readjustment. Hard to tell when the microscope is angled like that. Okay, that's just tacked. This is maybe hovering more than it needs to be, but I think it'll work. Alright, I'm happy with that. It's very hovering, but it's fine. It's not quite as bad as the crystal. Let's see, we got some more capacitors. These are the other crystals. Oh, I should find a 1 microfarad cap. I think that's the one passive I'm missing. That's right, I had them over here with my glitching stuff, because I was using them for glitching stuff. Here they are. I mean, yeah, that's right. I was tuning the voltage regulator on that other board with 1 microfarad caps. I think just, yeah, one of those. Right there. These are also 603. Yeah. Went all the way off the board that time. just slightly hovering this time. Okay, these are the crystal load caps. And I think I've got some here that are close enough. These are 27 picofarads. I think it's just these and then the connectors. And plug this thing into a Raspberry Pi. That was a mess. Let's make that less awkward. Grody tack joint. Let's take advantage of that and then make it disappear. I don't know if there's a good way to keep parts from sticking to your tweezers. Except maybe keeping your tweezers clean. I feel like I'm always getting my tweezers covered in flux and then wiping them off. That seems better. For a tack joint at least. Okay. It's ugly, but I think it's fine for a prototype. All right. Connector next. This seems pretty clean underneath. I think given how long this stream's been going on, I think it makes more sense to wrap this one up after we've got it put together and then do the testing on the next stream. So it's getting pretty late here. And I've been streaming for over 5 hours, and I still haven't eaten the other half of my sandwich. So I think I might do that after I put on these connectors. We've got a USB Type-B mini. I'm slightly surprised that this package is full. I thought I must have another roll of these somewhere. We've got one of these, and then some headers for the Raspberry. Ideally, I would have like a female header. Well, let's see what the Raspberry Pis I have look like. But I think the Raspberry Pi comes with a male header. And so this would make most sense if it was a female header that could just plug right on top. Alright. So I think just given that tilt under there, actually, first of all, let's make sure that won't short out anywhere. So that, yeah, the only conductive areas I'm seeing on here are, that would be like right around here. So this would just end up poking like right there. So that's fine. So we get better solder adhesion if we kind of tilt it back this way a little bit, but we would also get the opportunity to maybe have a straighter USB cable exit if we adjusted for that. So I'm going to do that, and I'm going to solder this to the board with a USB cable in it so that we have a chance to see what the angle is going to be like. So yeah, it looks like for the cable to come out flat, we want it to be about like that. So we can just tack down a couple of the solder joints with the cable held to the angle we want, and then solder the rest of the connections thoroughly. It's partially tacked on. I'm going to do one more on this side just because I can reach that easily, but typically you'd want to do them kind of diagonal from each other. Okay. I'm going to carefully remove that cable so I can solder the rest of it without the connector under stress. Not sure if removing the cable is the best idea because this seems dodgy, but I think it seems less sketchy than continuing to put stress on while I solder it, maybe. Alright. Soldering in 3 dimensions. That was ham-fisted of me. Just like fill it up with solder before it's even warm. because the glue on these boards is not as strong as on fiberglass boards, it can be nice to make sure that these have a kind of wide contact area when you can. Okay, those look pretty good. Okay. Let's put this header on, just to have all the soldering done. Then I think after putting this header on, that's our stopping point for this stream. Let's grab a Raspberry Pi just so I know what this is actually supposed to mate with. Are we out of flash card? I don't know whether that card's full or not. So, I think this is a Raspberry Pi 3. Yeah. Okay, so yeah, we want a female header for this. And just looking for where pin 1 is, so that I know which orientation this wants. That looks like pin 1. So pin 1. Huh. Oh, it wants to be like this, I think. Yeah, so imagine there's a connector there, and the light's not in the way. So, yeah. And that is bottom left pin 1. That's cute. So it just kind of gives you a little USB doodad for your Raspberry. So, what kind of header do we want? Is that 26? I think that's a 26-pin female header we want. I don't know if I have any of those. something that might be close enough. Let's see how many of these pins we need. Well, I've got these like little 8-pin single inlines that we could stack together, but that seems a little ridiculous. I might try to find something better. So maybe this is where I wrap up the stream. I will look for a header in the meantime. If I don't find anything, then I might just find some way to bodge this on in the meantime. But that is our completed thing. Completely untested, completely might not work, but on this stream we went from having just files in a Git repo to this completed board. So milled and cleaned up a bit and assembled using bits and pieces that I had handy. USB to Raspberry Pi. Focus. All right. Well, I think I'm going to wrap up this stream so that I can go eat my sandwich and play with Tuco. Thanks for joining me, everyone. I hope you found this interesting. The process of making a little doodad just in the shop with stuff that you have. So if you have any comments, definitely let me know in the YouTube comments or on Twitter. And if you want to be sure to get notified next time I stream one of these, the most reliable thing to do is to use the YouTube notification, so the little bell icon next to my subscription thing. And I try to schedule them as far out in advance as I know about them using the YouTube system, but I'll also announce them on Twitter and stuff like that. All right, I'll catch you all on the internet. Happy hacking.